Hello. Question number 8 on the midterm asks us to do several things with this set B here of vectors in R4. The first thing it asks us to do is show that the set is linearly independent. Now, the next question is related to this, so let's go ahead and see this next one. Now, supposing that it is linear independent, that means it's a basis for its span. And the question is this vector here in the span of B? And that's just a yes or no question. And the third part to question number 8 asks us to either compute the coordinates of that vector if it was in the span, or just to justify why it's not in the span. So if we look at these three questions, these are all the parts to question 8. What we see is that we can answer all three questions with just one computation. So in order to calculate if something is linearly independent, all you have to do is show that the rank of the corresponding matrix is equal to the number of columns, which involves computing the row echelon form for this matrix. Now if we look at the second part, this asks us to compute if this guy is in the span. And in order to do that, we would set up the augmentation with this guy's corresponding matrix on the left and this in the augmentation on the right. And then we would row reduce and put it in row echelon form, the left part, to check if it's in the span. And then on the third part, what we have to do is continue to put that matrix in reduced row echelon form to compute the coordinates, or we would just stop right there and provide a few words as to why it's not in the span. So what we can do for all three of these questions is just do a computation for part 2, and then that'll at least solve part 1 and hopefully also part 3. So let's go ahead and do that. We set up the augmentation where the coefficient part has columns equal to the vectors inside B, and then we put this guy on the right. All we have to do is put this guy in row echelon to figure out if it is in the span, so we go ahead and do that real quick. Here's the computations. We get this matrix over here, which is the row echelon form of the coefficient part. And what we see is that this bottom column here shows that we have an inconsistency in the system. So we get that this vector here is not in the span of B. So we can go ahead and just circle this guy here. No. No. Okay. And we can provide some solutions in part 3. But let's quick go over to part 1 and answer that, because we can see that the row echelon form of this matrix here is actually this matrix here. Okay. So let's move over to part 1. And let's show that it is in fact a linearly independent set. Okay? And all we have to do is we can see that from our work in part 2, we have the row echelon form of, let's say, A, which equals the matrix associated B, 0, 0, 1, 0, 2, 0, 1, 1, 1, 1, 0, 1, is, and let's go back here to remember what that guy is. It's this guy, 1, 1, 0, 0, 1, 1, 0, 0, minus 1, and a bunch of zeros. So it's going to be 1, 1, 0, 0, 1, 1, 0, 0, minus 1, and then a bunch of zeros. Okay. So the rank of A is equal to 3, which equals the number of columns of A, or the number of vectors in B, so B is linearly independent. So we've answered both 1 and 2. Let's quick go over to part 3 and provide an explanation. Boop, boop, boop. This was our work. Part 3, since we got that it was not in the span, we just have to provide a little reasoning for part 2, and we can say that since the system corresponding to C1 times 0, 0, 1, 0 plus C2, which is going to be 2, 0, 1, 1 plus C3, 1, 1, 0, 1 equaling 0, 1, 0, 0 is inconsistent. Okay, this is from our work in part 2. Then 0, 1, 0, 0 is not in the span of B. And that's it for this question. If you have any questions about this question or comments, then ask in the comments below or in class. Thank you very much.